In this video, we're going to be using the remainder theorem to determine whether a value of k is a zero of a polynomial. And a zero of a polynomial is a number k such that f of k equals 0. And remember, the remainder theorem says that f of k equals 0 if the remainder is 0 when you do synthetic division. In this example, also, we have a k, which is a complex number. So it's a little bit different from the previous examples that I've done. So in our problem, f of x is x to the fourth minus x cubed plus 6x squared plus 14x minus 20. And k is the complex number 1 plus 3i. Okay, now remember that we put our k value out in the little box in front. So I have 1 plus 3i out in front. And then I'm going to write my coefficients of my polynomial. Let me check and see if there's any terms missing. 4, 3, 2, 1, constant. No, there's no terms missing. So I'm just going to write 1. And then I'm going to give it a bit more space since I am going to need to write a real part and an imaginary part. So I have 1 here, and then negative 1, and then 6, and then 14, and then negative 20. All right, we start by bringing down our first number. So we have a 1 down here. Now when we multiply 1 by this binomial, I have 1 plus 3i as the product. I'm going to need to write the 1 underneath this real number, and then the plus 3i, I'll have its own little column over here, since this is negative 1 plus 0i, if I wanted to put that there. Now when I add these, negative 1 and positive 1 is 0, so those cancel, but I still have this 3i here. All right, now again, next step, I'm going to multiply 3i by this binomial out in front. 3i times 1 is 3i. I'm going to write that there. And then 3i times 3i, let me write this over here. 3i times 1 plus 3i gives me 3i, which I already wrote down, and then 9i squared. Remember, I squared is defined to be negative 1. So this is the same as 3i plus 9 times negative 1, which is 3i minus 9. So this minus 9, then, I can write that under the 6, because the 6 is a real number, and the negative 9 is a real number. So I have a negative 9 here, and then my 3i was positive. Right. Now when I add these together, I have negative 3 plus 3i. Now I need to multiply these two numbers. Let me do that right here. A negative 3 plus 3i is getting multiplied by 1 plus 3i. I'm going to have to use FOIL on this. So negative 3 times 1 is negative 3. Negative 3 times 3i is a negative 9i. Now my inners, 3i times 1 is 3i. And then 3i times 3i is 9i squared. Let's see, negative 3, these two combine to give me a negative 6i. This is the same as 9 times negative 1. So I have negative 3 minus 6i minus 9. So negative 3 and negative 9, those will combine and give me a negative 12 minus 6i. So now I can write that where my product gets written. Negative 12 minus 6i. Okay. And I'm adding here 14 and negative 12 is 2, and then negative 6i. Right. Now we need to multiply these two binomials together. So 2 minus 6i gets multiplied by 1 plus 3i. And again, I'm going to have to do FOIL on that. 2 times 1 is 2. 2 times 3i is 6i. Now my inners, negative 6i times 1 is negative 6i. And negative 6i times 3i is negative 18i squared. And I can see that 6i and negative 6i cancels. I have 2 minus 18 times negative 1. So I squared is negative 1. So this is 2 plus 18, which is 20. So that gets written where my product goes. And we can see that negative 20 and positive 20 gives me a remainder of 0. If you have a remainder of 0, then that means yes, this k value, 1 plus 3i, is a 0 of f of x.